Hi team, have you ever wondered how atom Q resources are allocated on a molecule? Well, if so, you're watching the right video. I'm going to take you through that right now. So here we have a sample molecule with a atom Q configured with the defaults, which is 25% of the heap allocated to the atom Q, 1% of each of the 1% of within the 25% is allocated to each Q and approximately 100 gigabytes of space allocated to persist messages. So with that, the 25% of the heap space is coming out of the overall heap space of the on the each node. So each node has about a gigabyte of space here. So 25% of that is available to the atom queue. And within that pool, 1% is available to each of the queues. So if I look at my queue management screen, I'll see a couple of different queues. So within that 250 megabyte range, which is 25% of a gig, 1% of that is allocated to each queue, which is about 2 gigabytes per queue, possible max. And then there's 100 gigabytes of space allocated per node to persist messages in the queue. However, it's not quite as it appears. So let's take a look at a log message that shows what the allocations are. This log message here shows up right after you reboot a node. There's a queue service create broker setting system limits, one for memory, queue memory, temporary disk space, and storage for messages. So this gets logged from the queue service, and I believe it's at the fine level. It is at the fine level. So this shows us 268, 435, 456 in memory. And if we go back to our browser, then we see here that it's approximately 260 megabytes, which is about 25% of the overall heap. So that's consistent. Then we see 268, 4354 for queue memory. So this is the 1%. So overall, there's 25% for the whole queue, but each individual queue is allocated about 2.5 megabytes of space of the heap for processing. Now the persistent storage is where things get a little tricky. So there is a parameter in the queue itself that 10% of the overall space per tenant is allocated to the queue. A molecule is a single tenant construct. However, only 10% is allocated for the actual queue storage. So the 10% gets broken up into 70-30. So 30% is allocated for temporary space, and 70% is allocated to message allocations. So if we see here that temporary space is about 32 gigabytes of the 100 gigabytes, that matches this number, the 322 ends in 768. That's this number here. And then the space allocated for actual messages is 75 gigabytes. 751 ending in 632, 751 ending in 632. So 7 gigs per node of the 100 gigabytes allocated on the file share by default for messages is really available for your message contents. And the only way to address that is to dramatically increase this number, which is a per node configuration. So if I doubled it to 200 gigabytes, that would allocate 14 gigabytes of space for my queue. So that is the solution to the problem. If you're running out of queue space, you have to basically double this to double the 7% that's actually allocated for space. All right, I hope this was helpful. Thanks again and happy integrating.